Right, here's the challenge. How do we build and heat our homes without overheating the planet?
Net zero.
Net zero.
Net zero.
So net zero is the plan, but how are we actually going to get there? Because our buildings are responsible for 28% of total CO2 emissions. And when you add in emissions from building those buildings, that number goes up to 39%. So how on earth are we getting to net zero? Luckily, scientists and experts have been working for years on this. I've been speaking with some of them and going through the advice and evidence of many more. And one thing is definitely clear. We're gonna have to do something about our buildings, especially how we heat them.
Heat is around half of the energy that's used around the world, half. And the emissions from heating are about a third overall. Gas is by far the biggest way that we produce heat, not just in the UK, but around the world. In the UK, we are a particularly gassy country. About 85% of homes are connected to the gas grid. There are about 23 million homes with gas boilers. And while gas is slightly cleaner than burning oil or burning coal, it's still a fossil fuel. So it's all got to go.
Right, so swap out 23 million boilers. There's a little bit of a logistical challenge there. But more importantly, what are we going to replace these with?
There is an idea that you could just convert the existing gas grid to run on hydrogen. That would be piped into people's homes and then burnt in boilers, much the same way it is now. But burning hydrogen for heat looks like an extremely expensive and inefficient option.
Right. What else could we do then?
It looks like heat pumps will be the cheapest long-term option for most people.
So a heat pump, as the name suggests, it pumps heat from the air, the ground, or even rivers and the sea into your home.
A gas boiler might be 80 or 85% efficient, but a heat pump will give you about 3.5 units of energy for every unit of energy you put into it. So that's 350% efficiency. They're just so much more efficient than a boiler will ever be.
Sounds a bit like a no-brainer, but there's still a few hurdles to overcome because heat pumps are still pretty expensive. And putting them in can be a complex operation, maybe requiring new radiators and insulation.
It shouldn't be a personal responsibility. There should be help for people to do this. So it's the role of government to make this really easy for people. You should be able to phone up an advice line and be offered grant funding or offered a free or low-cost loan and be able to do this at no upfront cost and no upfront hassle to yourself.
The reality is that anything like that seems pretty far away. And in 2019, the UK's Climate Change Committee said that over 10 years after the Climate Change Act was passed, there is still no serious plan for decarbonising UK heating systems. So yeah, still some huge challenges to overcome for these to be a viable option in our homes. And of course, that's just one aspect of making our buildings net zero friendly. There's still things to think about like electricity and insulation, but this is all just about our buildings as they are. What about building? Constructing our homes. Because at the same time, the global population is still rising, and that means the need for new housing and the materials to build it with is going to rise too, specifically concrete.
Concrete is the most widely used material on the planet after water.
In 3 years, China consumed more cement, the glue that holds concrete together, than the US used in the entire 20th century. And if cement production were a country, it would be the third largest emitter in the world. And that's a lot to do with the production of clinker, the key part of cement. Because turning the raw materials, mainly limestone and clay, into calcium oxide produces a lot of CO2, just part of the process. And producing concrete also uses a huge amount of water. In 2050, an estimated 75% of this water will likely be taken from regions that won't have enough to satisfy human needs. So how do we reduce its environmental impacts?
Everyone might think that the best way to do it will be using less concrete. But that will also bring quite a lot of social inequalities because we need infrastructure for living.
So other options include recycling concrete and waste CO2, reducing the amount of clinker, or swapping it for other materials. And there's even self-healing concrete, like this, with an enzyme in it which responds automatically to cracks. In 2021, cement makers around the world did pledge to cut emissions by up to 25% by 2030 to reach net zero by 2050. So that's some ambition being shown, but we have to interrogate this a little bit further because that plan relies on carbon capture. And there's two things with that. Firstly, it could make concrete much more expensive. Who's paying for that? And number two,
we still need to answer the questions of what we're going to do with that CO2 once it's under storage.
So in order for the industry to transition to low carbon, it's not just technology that we need.
There are many things that could be done just now, but we don't have the right policy or the right standards that enable us to actually adopt it rapidly into practice. Concrete is a material that we take for granted. We think, oh, it's not sophisticated, it's not beautiful, so it might not be interesting. But when we think about the vast amount of concrete that we actually use in our society, we need all hands in deck to try to make this material more sustainable, more efficient, so we can continue using it for the many years to come to resolve our infrastructure needs.
Okay, we've only just scratched the surface of these two huge topics, but when it comes to net zero, there's a lot of chat about things we need to cut in our lives, but there's a lot of positives too, especially when it comes to our buildings.
So a dream outcome for me in 2050 is that we're all living in houses that are warmer, quieter, cozier, and cheaper to run, and we've met our climate change targets. That would just be fantastic.